In this video, I'm going to introduce conditional probability. So we have a random sample of 84,550 doctors, both males and females, pathologists and pediatricians. Okay, so one doctor is randomly selected. First, let's calculate some probabilities that we know how to do. So let's calculate the probability of randomly selecting a male doctor. Okay, so let's try that out. The probability of getting a male doctor. So I'm going to use M for male. Well, let's see how many male doctors are there. If we add these two together, that's how many male doctors are in this sample, which we already have a total column, so it tells us over here what that sum is. We have 45,595 males. Divided by the sample size, 84,550. Okay, so if you divide those two, you should get 0.539. So the probability of selecting a male, slightly more than half. Okay, all right. Next, let's find the probability of randomly selecting a male pediatrician. So that's basically probability of being a male and a pediatrician. All right, so let's look at our table. How many male pediatricians are there? So right here, these guys are both male and pediatricians, right? So 33,020. So let's go ahead and write that. So 33,020 out of the 84,550 in the sample. That'll give us the probability of being a male and a pediatrician. So that's 0.3905. Okay. All right. Lastly, let's calculate the probability of selecting a male given that the doctor, lastly, let's calculate the probability of selecting a pediatrician given that the doctor is a male. Okay, so the way we would write this is we would say, okay, so pediatrician, and then we use this bar. This bar means given, male. Okay, so you'd read this, the probability being a pediatrician given that the doctor is a male. All right, so how are we going to do that? Well, one way of thinking about it is looking at our data. One way of thinking about it is only the men are our new sample, basically. We no longer have the 84,550 people in the sample. Now we only have just the men in the sample, right? Because it's been given that that the person that was selected is male. So this now becomes basically our new sample. It's just these two columns, or these two numbers here. All right, so now we're trying to figure out the probability of them being a pediatrician given that they are part of this male group. So that would be 33,020 divided by the 45,900 or 595. So let me go ahead and write that down. Divided by 45,595. Okay, so that equals 0.725. Well, there you go. This is a conditional probability because it is conditional on the doctor having been selected a male. Okay, so this is a conditional probability. Now, another way that we could have calculated this is using the conditional probability rule. So let me go ahead and show you what the conditional probability rule is. Conditional probability rule. The way that we calculate it is definitely the easier way, but we could also consider the rule. So let me go ahead and give you what the rule is. The rule is that the probability of A given B equals the probability of A and B divided by the probability of B. All right, so we could use this. We calculated, so this means that this probability would be the probability of pediatrician and male divided by the probability of being a male. Okay, pediatrician and male, the probability of being both a pediatrician and a male was the answer to part B, which was 33,020 divided by 84,550. Okay, divided by the probability of being a male, which was the answer to part A. Let's scroll over a little bit more. So that was 45,595 divided by 84,550. Now, if you remember how to deal with fractions on top of fractions, what you do is you multiply the numerator by the reciprocal of the denominator. Okay, so let me go ahead and do that. So this would be 33,020 divided by 84,550. Okay, and then multiply that by the reciprocal of this number here. So that'd be times the reciprocal, so flip it around, 84,550 divided by 45,595. Okay, you see these cancel, and what you're left with is 33,020 divided by 45,595, which is the same answer that we came up with before. So this equals 0.725.